No.
Everything you say is recorded from this point forward.
Okay.
Okay, so this is the warm up for today. If you're watching along at home, if you're streaming live, nobody's streaming live. Pause it here. Do these problems, then we'll go over it. Okay, so Brad, what do I do first to find the intercepts?
You gotta put them divide y by 0.
Plug 0 in for y. Is that what you mean? Yeah. So when I do that, what do I get?
0.
Okay, but what is the equation that I get if I put 0 in for y?
X equals 18.
You mean 2x equals 18? Wow, you're on a roll here. Call you butter. You're on a roll.
Oh, yes. Really good joke. Wow.
Sorry. Apologize. Don't pound on the desk anymore, Jack. Okay, so what do I get for my x value, Brad?
9.
Good. What does that tell me about my coordinate? What is my coordinate then?
9. Oh wait, 9, 0.
9, 0. Why am I stressing that? Because I will be taking off points. If you do not put the coordinate correctly, I will be taking off points. All right, so my x coordinate is 9. Let's say, Addie, Stern, how do I find my y-intercept?
Replace the 2 with a 0.
And get?
6y equals 18.
Good. And then finish it off.
Divide by 6.
To get? 18 divided by 6 is?
3.
Which is the coordinate what? 0, 3. So now we go to graph these two. 0, 3 is right here. 9, 0 is right here. Now, I was walking around, not this period, earlier today, and I saw a lot of people do this, which makes me very cautious to go and grade your quizzes. Because is that okay? No. That is not okay. I need to do two things. Shh. I need to extend it through and put arrows on the end. When would I have drawn a graph that would have stopped? In a word problem. Then I would have drawn a graph that would have stopped. Okay. Shh, people, we're talking way too much. All right. So we have 3x plus 6y is equal to 12. Colin, what do I have to do to solve this one to put it into slope-intercept form?
Minus 3x.
Good. So we subtract 3x. Now, I had somebody say to me, I think it was a couple days ago, could I write it 12 minus 3x? And I was like, that just looks weird. I always put the mx before the b. I always like to write it negative 3x plus 12. I mean, if you identified the slope and the y-intercept correctly, it doesn't matter. Sure, go for it. Finish it off there, Colin.
Divide 6 on all sides.
To everything. And I get y is equal to what?
0.5x.
Ooh, shame. Can you put decimals as a slope?
No.
So 0.5 should be what instead of 0.5? 1/2. And good. Negative 1/2 x. Redeem yourself. Plus
2.
plus 2.
That's a good call.
We all make mistakes. It's okay, man. All right. So my question goes to Jack. What's my slope, Jack? Jack, what's my slope?
N is negative 1/2.
And what's my b value?
2.
Okay. So when I go to graph it, where do I go? Where do I start?
2 on the y-axis.
Good. Up here. Not to the right, to up to. Okay, tell me where to go from there.
Down 1, right 2.
Good. And then we can keep going. And if I were to go up, then what would I do?
Up 1, left 2.
Good. Makes the same slope. That is a negative sloping line. Okay. Questions about that? No? Okay. So let's talk through the review from sections 3.1 to 3.4. Same type of thing as I did the other day. This is not really like new notes. This is just a worksheet for you that we're going to do in class to kind of, help you along the way. The problems are all on here, so you don't have to worry about copying anything down. just thought this might make class go a little smoother. So, now, for the test, quiet please, listen to me. You're going to want to hear this. Telling you exactly what's on your test. For your test on Tuesday, we just constructed the test. We just finished making the two versions for the test. The test is a combination of both of the quizzes, okay? The test is a combination of both of the quizzes. Now, when I say both of the quizzes, what do I mean? I mean the 3-1 to 3-4 quiz that you took a while back, the one that, as a class, we did so hot. That 3-1 to 3-4 quiz, the one that I had you guys, we could have done a retake on that. And then the 3-5, 3-6 quiz. Now, what did we do to make the test? Well, we just combined everything into one document, all the problems into one document, and then we took some problems off and reordered and changed numbers and kind of, if the word problems got changed and whatnot. But all of the problems on the test look exactly like problems that were on the quizzes, okay? So if you want to know what's on the test, you look at your quizzes. Now, I understand I haven't given back to you the 3-5, 3-6 quiz. Tonight's conference night, I'm going to have a lot of time, only got a couple conferences, so I should be able to grade them tonight. Fingers crossed that nobody comes and bugs me. So I should be able to grade them tonight to give back to you tomorrow to review, okay? So those two quizzes together. Now, is every question from both quizzes going to be on that test? No, that would take you like an hour to do. No, we're not going to do that. That test is, we combined the quizzes and we took off problems. We didn't add in any new problems. All we did was take off problems. So if you want to know what's exactly on the test, you look at your two quizzes once you get the second one back. Now that means all the stuff from the section 3-1 to 3-4 quiz is on that test at somewhere. Okay. So let's start at the very beginning, section 3-1. We talked about what is a function. Well, how do I tell if, like say number 1 here, how do I tell if that's a function? How do I tell if that's a function? Addie?
Isn't it if each y value has its own x value?
Good. I'm glad she stated it that way, because you know what somebody said to me every other period? If x is going up by a constant rate and y is going up by a constant rate. That is not to tell if it's a function. That's telling if it's a linear equation or not. Not necessarily that it's a function. Here's what I mean. Okay. Are there any other 0 commas other than this point? Nope. Any other 5 commas?
No.
Nope. 7?
No.
Nope. 8? Nope.
No.
So is this a function?
Yes.
Yes. We can say that this is a function, and the explanation would be each x value has only one y value. Okay? Each x value has one and only one y value. Okay? Now, I know this is kind of deviating away, but can anybody tell me a point that I would put on there to make it not a function? Can anybody give me an example of a point to add into this list that would make it not a function?
You said it was 0, 1, 5, 1?
5, 1. Sure, I'll add that right onto the end of the list. Is that a function anymore? No, because I have 2 5s. So if you say no, you have to tell me, okay, 5 makes it not a function anymore. Good. All right, so let's take a look at number 5 here. Okay, I know the numbering skips around. My original thought was to tell you to do this for homework, like last night after the quiz, and then go over it today in class, because these are all book problems, but I decided just to do it as like an in-class assignment anyway. You'll notice, is there anything written on the homework board?
No.
Oh my gosh, I must be.
I noticed that.
I noticed.
Man. I don't know what's going on with myself. All right, now, don't let me put homework. Let's take a look at A, B, and C here. First off, is this, Corey, is this a function? Is this a function?
Yes.
Well, those are the 2 options, Corey. You are correct. It's either no or yes. You say yes. Why? Because it says explain.
Oh,
I don't know.
What is this thing that I'm doing here?
Oh, the vertical line.
Yeah. Does each of those vertical line hit once and only once?
Mhm.
Yes. So it is a function, and why? It's because it passes a VLT. Now, for my next question, part B says, identify the domain. Now, whenever we're given a graph like this, whenever it's a continuous domain, meaning all points in between, remember that we write it like this. I got some really funky notation on the quiz. Like you guys were doing some weird stuff that it's like, that's not even close to right. But what do I look at here? I look at left to right. So let me ask you, Cassie Soima, what is the farthest left it goes? How far left does this function go?
-2.
Oh, be careful.
-3.
-3. How far right does it go, Cassie?
-3.
+3. Good. And that's how we write it. You know what I got on the quiz? People were writing it like this. No. Somebody wrote it like this. Like -3 to 3. No. You can't do that. It's got to be written like the inequality. Okay? Okay, now, to identify the range, same type of thing. But now instead of left to right, I go up bottom to top. So Josiah, what is the range here? What's the farthest down it goes? -1. Okay, now remember that you go total with the function, right? Just because the end point is up here doesn't mean it's like 2 to 3. No, it goes all the way to -1. And then what's the top end of this thing, Josiah? +3. Good. All the way up. That's the highest point of this function as well. Okay. Questions about that? All right, let's keep it going. Oh, our good friend. This problem. This is the one where I have to write when is it positive? When is it negative? That's an e.g. Negative. When is it increasing? Shh. If I hear you talking, I assume you just want to do the next problem. And this is a doozy. Okay. If anybody would like to hear that back, that would be at timestamp 1310. Anybody would like to listen to that back? Okay. Wow. Okay. Can anybody tell me when, looking at the graph, when is the function increasing? Or sorry, excuse me, when is it positive? When is a function positive? Good, when it's above the x-axis. So I'm going to go in and I'm going to say here, that's when it's above the x-axis. So what x value does it start going above the x-axis? Addie? What x value?
-1.
-1. And all the way until, notice I'm not going to do equals, all the way until +1, it stays, the function stays above the x-axis. Okay, negative. When is it, if it's not positive, then obviously it's negative. So all points down here or here. Okay, so any number to the left of -1, if I plug that in, it would be below the y-axis, or excuse me, x-axis. I write that as x is less than -1. Now, sometimes I write an and, sometimes I write an or, sometimes I write a comma, because there's another piece to this. There's another spot where it goes below the x-axis. When does it start going below the x-axis? At +1. And every point beyond that, it's below the x-axis. Okay, increasing, decreasing. Now, if a function is increasing, remember this is like when I put the roller coaster on it, and if it's chugging up the hill, then it's increasing. If it's going down the hill, then it's decreasing. Okay, so at all points to the left, it's increasing. Where does it switch to going from increasing back down to decreasing? What x value does that happen at? What x value does it switch from increasing to decreasing? 0. Good. People have told me 1 all day. That's the y value, folks. That I need the x value. I always talk about it in terms of the x value. So anything to the left of 0 is increasing, and everything to the right of 0 is decreasing. Now, I don't have the blanks on my paper here like you do for the end behavior. Remember, it says as x goes to infinity, as x arrow infinity. That means as x goes to the right, because it's positive infinity, y goes to, now, for end behavior, what's it doing on both ends of this thing? It's going down, right? How do I write going down? Negative infinity, right? So it's going down on both of those. So you can fill in your blanks there, negative infinity for both of them. Because on the left side and the right side, this function is going down. Okay. Questions about that? All right. So determine whether the table, graph, or equation represents linear or non-linear function. Okay, now this is when I look at the change in. This is when I see, okay, the change in x as it pertains to change in y. What is the change in x? Today, it is really cold in my room.
Yeah.
Today. Lizzie, what's my change in x?
+5.
Good. And what's my change in y?
-3.
Good. So it's constant throughout. So what can we say? Is it linear? Yes. It is linear. And if we need to explain, which you will have to explain just like you did on your quiz, you would say constant change in x and y. And I'll need to see, just like I did on the quiz, I'll need to see what the changes are, just to make sure you got that right. You didn't guess at it. Okay. Now, this came later, but what is the slope of this linear equation? Now that we call it linear, what's the slope? Yeah. -3 over
Oh, 5.
over 5. Yeah, the slope is -3 over 5 because it's the change in y divided by the change in x. It didn't ask for that here, but still, we could have said that. Okay, easiest question of the day. Is this a straight line?
No.
No, it's not linear. Okay. We're doing that. Not linear.
Non-linear.
See, because of that. All right. Now, 15 and 16. I gave you 2 problems that are not linear. I gave you two. I'm telling you right now, these are both not linear, but what I would like to talk about is what makes them not linear. What about the equations that you see are not linear?
One of them is the red division.
Okay, and I'm dividing by an x, right? That makes it not linear. Be careful if you say there's division, because is that linear?
Yeah.
Yes, because even though there is division, I'm just dividing by a number. What can't I have happen? Dividing by what? Dividing by x or y. Okay, why is 16 not linear? Why is that one not linear? Oh.
Because you're multiplying two variables.
Yeah. So that makes it not linear. You cannot divide or multiply variables together.
Let's see.
All right, let's take a look at a word problem. All right, so we have the function y is equal to 60 minus 8x, and it represents the dollars y of money you have after you buy movie tickets. Sorry, my graph kind of cut off part of the problem there. You see it on your paper. Represents the amount of money you have left over after you purchase movie tickets. Let's talk about what each piece of the equation represents. So it asks you to identify, what is the 60 representing? What is the 60 representing? Viva?
The money that you start with.
Good. The starting money. Starting money. Starting money. Before buying tickets, right? All right, what is the 8? What is the 8 then? Somebody tell me. Okay? Cost per ticket. Good. Okay, then what is the 8x? What is the 8x, Addie?
Is it ticket per person?
Not exactly. Levi?
It's the amount of tickets you buy.
No, that's x. Cassie?
Total cost of tickets?
Total cost of tickets. Okay. So then it says, find the domain of the function. And then talk about whether it's discrete or continuous. Okay. Now, the domain. Remember, when identifying the domain, we have to talk about what are the possible x values. Okay. Is it possible to have negative x values?
No.
I can have negative movie tickets?
Wait, no, not
No.
in this game.
Is it possible to have 0 movie tickets?
Yeah.
Sure, we don't have to go to this thing. Is it possible to have 1 ticket?
Yeah.
Is it possible to have 1.5 tickets?
No.
No, it is not. So 1, 2, 3, 4, 5. I slow down because could I buy an infinite amount of tickets?
Yeah.
Here's the problem. What did we identify 60 at?
Starting money.
Starting money.
Oh.
So I have to figure out, when am I going to run out of money? Yes.
I was going to answer it.
Go ahead.
Oh, you'd have to divide 60 divided by 8.
And what do I get?
7.5, but you can't have half the ticket, so you'd have 7.
Good. Now, can I purchase 8 tickets?
No.
No, because I get 7.5, right? I cannot purchase an 8th ticket. I would have to spend I don't have that much money. It would be $64, right? And I only have 60. Now, is that domain discrete or continuous? Just remember, discrete is single solitary points where I cannot have decimals, which is what's described here. Continuous is if I, I could have any value in between there. Like 2.2 would be a valid solution, but it's not here. Okay, now it says to graph the function using its domain. Now, make sure you label your axes. This is tickets, and this is money left over. Money left over. Not money, not total cost. It's money left over. Now, I can go by 2 boxes every time for my domain. So I'm going to say 1, 2, 3, 4, 5, 6, 7. Fits perfectly. Now, how much do I need to go up to on my y values? 60, right? 60. So let's go by 2 blocks is 10. 10, 20, 30, 40, 50, 60. Okay. If I spend no money, I still have 60 bucks. What do I get if I spend one ticket? Or how much money do I have left over if I purchase one ticket? I started with 60 bucks.
Wait, sorry.
$52. So I would have $52. Okay, what about 2 tickets? What am I doing here? I'm basically making a table of values. 1, 2, 3, 4, 5, 6, 7. And when I say plug in 1, I mean I get 52. When I plug in 2, I get 44. What's it going down by each time? 8. So let's keep that pattern going. 36, 28, 20, 12, and 4. Just went down by 8. Would that make sense? Like, say I plugged in 6. 60 minus 8 times 6, 48. 60 minus 48 is 12. Yeah. All I'm really doing there is just plugging in those values. So 1 comma 52, 2 comma 44, 10, 20, 30, 44. 3 comma 36, 4 comma 28, 5 comma 20, 6 comma 12, and 7 comma 4. Do I fill in my line? No. The reason? Right here. Okay? Discrete means dots. Questions about that? Okay, we are only going to do the 2 problems on the top. Okay. You know what I'm actually asking you to do here on the top of the back page? I'm asking you to find f of -3, f of 0, and then f of 5. Now, what is that notation telling me to do? Levi? What is that notation telling me to do? Say f of -3.
It's kind of the F, you equate it with or 5.
Exactly. It's telling me to go into the equation and plug in whatever's in parentheses into the equation. I had so many people like setting this equation equal to -3 and then like setting it equal to the no. That's what's going in for x, folks. Like -3 plus 8 or 0 plus 8 or 5 plus 8. And then you just evaluate. F of -3 would get me 5. F of 0 would get me 8. And f of 5 would get me 13. And now we do the exact same thing for the other problem. I want to find h of -3. h of 0. And then h of 5. Which means 3 times negative 3 minus 9. And if I were to plug in that, that's just negative 18. This would be 3 times 0 minus 9. And if I were to plug that in, then we would just get negative 9. And then 3 times 5 minus 9. Okay, that would be 15 minus 9, or 6. See, all I'm doing there is just plugging in those numbers. Now, why am I not doing the last problem? Why am I skipping that one? Well, back in section 3.1 to 3.4, do you know what I would have used with my x values in that table? Remember what we used? Yeah, negative 2, negative 1, 0, 1, 2, right? Do we have to do that anymore?
No.
No. Like, what would be the easiest way to graph that function that you see there? What form is it in? No. Slope-intercept form. The slope is negative 2, the y-intercept is negative 3. Should we be using those like that, those 5 points, negative 2, negative 1, 0, 1, 2? No, we don't need to do that because we know better now. See, back on the 3.1 to 3.4 quiz, we didn't know that yet. We didn't learn that yet. So we were stuck using negative 2, negative 1, 0, 1, 2. But now that we've learned that, we don't have to do that anymore. We can just use the slope and the intercept. See, going back to your 3.1 to 3.4 quiz, this is why I put this one on there. Going back to 3.1 to 3.4 quiz, there are questions that we know how to do better now that we know how to graph using intercepts and graph using slope intercept. So those are the ones like we took off from the first quiz, basically. Okay. All right, I'm going to stop the video here. So long, everybody.